Okay, let's do this question. Took me a couple tries and a couple of failed attempts to try to explain this, but I think I have a good explanation. So, you have a circular route of gas stations, and you want to travel around this circular route. But the thing is, if you don't have any gas, obviously, and it costs a certain amount of gas to get to the next station, obviously you're kind of stuck. So you need to choose a station such that it is possible to get around the entire circuit. So at each station, you're given the amount of gas that they offer, and the cost it would get to, how much gas it would take to get to the next station, which is the cost. So how do we know which index to choose, which station to start off with? And they say the solution is guaranteed to be unique. Well, one observation is, if I take the difference between the gas and the cost, and then sum them all together, I get a total total net gas that I can accumulate. If the total net gas is less than 0, then I know it's not possible. If it's greater than 0, I know it's greater than or equal to 0, then I know it's possible. The thing is, the hard part, I guess, is trying to find out which station to start off with. So we could try a brute force approach. Brute force approach would just start, you'd pick the first station, travel along, and as soon as I get to a negative amount of gas, I stop. So I'm going to travel along here. Okay, 0 gas. But I get to here, which causes my gas to be negative. So then I stop. And then I would try this index again and go through. Okay, stop. My gas is negative. Then I try this index. Stop. My gas is negative. There and there. Okay, so that's kind of n-squared approach. But the thing is, we can optimize that a little bit. N-squared might take too long because it's 10 to the power 5. If I start at the first station and I know this will result in a negative value, I know up to this point here, before I touch the negative, the net gain is positive. So if I start at a later position, the gas I've accumulated up to the station before I have negative costs would definitely be less than or equal to the gas I would have accumulated if I started earlier. So there is no point in checking once I start at this index and find that at this point it's negative gas to start at any of these intermediate positions again. So once I find that this results in a negative value, I could chuck all of this away and start here. So that results in a linear time solution. And only if I can find basically the first station where I can get to the end of the array and have total gas greater than or equal to 0. Well, I know that that's the solution if and only if the total amount of the total sum of differences is greater than or equal to 0. So let's just do this example. You have 0. If this is the gas, all right, and this is the cost. The differences here would be 0, 0. So I'm just subtracting the first one from the second line. This is -2. So let's actually take this. This is 0, 0, 0, 0. This is also minus 2. And then here you have positive 4. So these are the differences. So I can start at this index, go all the way here. There's no point starting at this index to try, because I know that it will be negative. So once I find out that this part is negative, I can start here and go all the way here. That's negative. So then I start here. And then since this goes all the way to the end of the array, this is the possible answer. It's either this answer or -1 if there's no solution. So as I go through, I can also accumulate the total sum of differences. And if that's greater than or equals 0, then return this index here. Okay, let's try that. So I need the total sum. And I also need the current sum. Also need the answer that starts at 0. Then I can go through int I is equal to 0. I less than gas.size plus I. Then I need to calculate the difference. So difference would be the gas I minus the costs. And then I could add that to the total and to the sum. But if the sum is less than 0, then that means I want to start the sum again. But the answer would be equal to I plus 1. So not the current one, but the next one over. So at here, I find out that the sum is negative, so it will be minus 2. So I want to start the answer to be 1 over that here. And then that would, so I'll start here and then realize it's negative here. So then I start the answer here. So now when this loop exits, answer would be at this index. Then I just want to make sure that this total sum, so return basically if the total is greater than or equal to 0, then return the answer, otherwise -1. Sum is not declared because it's called current sum. So I have had a couple wrong attempts before. This is linear time, so I'm not sure why it is so slow compared to everyone else. And with space as well, so I'm guessing they've added new test cases, because I don't think you can get a better time than linear time.